Thanks moderator Cao Lei, and this is Dr. Ouyang, and very happy to be here. And thanks for the invitation from Ms. Huang and from GTI again. I remember last couple of months we shared some pilot progress in the last meeting in GTI in Turkey last year. Now it's time to share some further ones that we have made, that we have co-worked with China Mobile in the space of the wireless network intelligentization, and also specifically for the specific goal in terms of what? In terms of the wireless optimization. So 3 keywords that we want to address today, based upon the title over here. The first keyword is user experience. It's not network performance, it's the network user experience that we, at the end of the day, that we want to address this topic. And the second keyword is what is the QoE optimization. It's still about user experience. Our goal is to optimize the user's quality of experience. Then the number 3 keyword is what is the multi-agent reinforcement learning. That is methodology that we applies to address the problem. 3 keywords. And also, first about AsiaInfo technologies. This is telecom software, the China's largest telecom software. 30 years to now, we focus one thing only, which is to construct the complete telecom software infrastructure from 1G to 5G. We are the first China's high-tech listed in NASDAQ 24 years ago. And then we delisted ourselves and moved to the Hong Kong's stock market 6 years ago. And then also China Mobile invested AsiaInfo in 2020 and took us the 20% of the stake from AsiaInfo. That basically history from AsiaInfo. All right, that is the roadmap of AI and the telecom AI. This picture I displayed it so many times, but I want to subset some specific milestones from this general roadmap, which is here. Our key topic today is we want to look for a smart way to optimize our network in terms of automation and artificial intelligence. So a subset of the keywords in this space. In what space? Wireless network optimization. First, let's look at the 3GPP part. I would say 16 years ago, back to 2008, 3GPP first time brought up the new idea, the SON, the self-organization networks for 3G. And then back to 2017, the year 1 of 5G. And then also 3GPP brings up the 5G SON initiative. And then autonomous networks start to boom up in 3GPP, in TM Forum, and all the other standard bodies. That is the progress in the standard part. And then let's look at the industry. A lot of the key pilot practices have been made by telcos in the past 20 years in this space. Some typical events that are listed here. Verizon, AT&T, they employed some typical vendors, some solutions for their 3G and 4G networks in the past 15 years. Particularly, AT&T leveraged the SON solution from Irish company, not Irish, Israel company, Intercell, which was acquired by Cisco, that is in the third column over here, 15 years ago. And then Verizon also used Intercells and also the Cell Sites, which is another SON company based in the US for their 3G and 4G networks. This company was further acquired by Amdocs, also in a couple of years ago. That was the initial pilot studies by telcos in North America. And also both Verizon and AT&T start to leverage their own self-researched products for some solution in 4G era. And then in 5G, China Mobile have made a lot of the pilot studies and also pilot practices for the network intelligence solution to optimize the wireless networks. And also some of the key practices in 5G was also further merged with the initiatives of the autonomous networks. That was basically the historical milestones in the wireless network optimization space. All right. Okay, that here from this page we start to face the most 5 key challenges in developing the advanced self-intelligence of the wireless network optimization. Let's look at the 5 key challenges over here. First is the lack of the automation tools. Until now, many telcos still employing tens of thousands of engineers who drive their cars to optimize the network every day, which means we still do not have sufficient and effective the automation tools to optimize our wireless network. Number 1 challenge. Number 2 challenge is still the problem of the data. We have since 4G until now 5G, the top 4 telecom vendors OMC generates sufficient performance, signaling data and traffic data. However, their data are still not fully connected and correlated with each other from layer 1 to layer 7. And also the problem of the data quality is still a serious challenge to us. Insufficient user level data. We have a performance data, we have the RF data in layer 1, 2, 3. However, all these data in layer 1, 2, 3 are not effectively connected or correlated to the user experience or user behaviors in level 7. So these dots are not fully connected with each other. And then number 3 is the inefficient legacy simulation methodologies. In the past, I would say most of the simulation tools like MATLAB, AutoNet, all these simulation tools are still focused on simulation and network layer. Still, we do not have the effective simulation tools. And also, China Mobile Research Institute started to introduce the new technology, network digital twins, otherwise digital twins network, to be a next generation of the effective method to evolve the traditional simulation tools. That's the number 3 challenge. Number 4 challenge, I highlight this challenge more, which is the gap between the network performance and user experience. The ultimate goal for any engineers in any telco is to optimize the network performance. However, on the other hand, the customer care department in each telco is to improve the customer satisfaction rate. There is a gap between the network performance and the network user experience. So that is the key point that we want to address, that we want to roll out a bridge to address this gap. Number 4 challenge. Number 5, experience-driven optimization. The expert experience is no longer feasible or capable to address all the network optimization problems. So I still spend 1 to 2 minutes to address these 5 challenges. However, in response to these 5 challenges, we co-work with China Mobile to develop the 4 key technologies in response to these 5 challenges. And number 1 is the key of the key that I want to introduce for today, multi-agent reinforcement learning technology. Number 2 is the wireless network coverage simulation and prediction algorithm portfolio over here. And number 3 is the measurement report-based high-level positioning. Number 4 is the network digital twins. All right, that is a mapping relationship between the 4 key techs to address the 5 challenges, which is for what. I don't want to repeat over here. Share the slide deck with everyone after my talk. I will introduce the key-tech 1, 2, 3, 4 one by one. The first is the key-tech 1, the multi-agent reinforcement learning methodology over here. I would say it is an optimum solution for decision making in the very complex environmental scenarios, along with the complicated iterative behaviors. This methodology presents and models the complicated network scenario and effectively explores the optimum solution in large-scale searching spaces. So, based on such particular characteristics of this algorithm, obviously this algorithm helps us identify the optimum coordinated beam-forming vector portfolio in optimizing the Massive-MIMO performance for the G-node B antennas. That is the key factor of this algorithm. All right, and then let's see the validation results that we apply to one of the biggest cities in China, Tianjin, China Mobile Tianjin office. Let's see the key validation results and the key benefits. Let's look at the algorithm side on the left. The algorithm-wise, the reward effects is improved by 10%, and the performance of the algorithm, we call it the convergence rate, is improved by 300% up to 3 times. And then in the network performance aspects, the most typical KPI, the ISRP performance, is improved by 1.8 dB in the area of the 1K square meters. That's a very significant improvement in terms of the coverage. And that is the number 1 key tech. So number 2 key tech is, I would say, is the simulation and the prediction. But in other words, I call it a reinforcement learning-based retracing plus the MDT and MR-based fingerprint data analytics method over here. Look at the left side, the three typical problems in simulation. Particularly the simulation for the network coverage. And number 1 is the accuracy. It's poor accuracy in terms of our simulation. Number 2 is the simulation results is not truly reflecting the network service distribution. It only reflects what's the distribution of the network coverage. So there is still a bridge between the network coverage and the actual level 7 network service distribution over here. And then number 3 is the limited external validity of the simulation. I make a simulation algorithm set for this area, but the algorithm itself is not generalized and capable applied to the other area. External validity is not very strong. But we do believe this key tech is capable of addressing these 3 problems over here. And then let's look at the validation results over here. First is the accuracy. Accuracy-wise, we leverage the indoor building layering model to simulate and render the coverage at granularity up to 3 meters. That is very fine granularity over here that we have applied. With what? With an ISRP deviation error at 4.7 dB over here. On the other hand, on the right side, in the rotor coverage simulation, we support Massive-MIMO and beam-forming simulation. I would see more than 98% of all the roads can be simulated with our method and tools over here. That is the application results. The third key tech is about the MR and MDT based positioning. Everyone knows obviously the legacy method to do the positioning is called triangulation, but everyone also knows the performance and the accuracy is pretty bad with the legacy positioning methodology. But basically, we applied a new method over here, including 2 key steps. So step 1 is we utilize the XG boost based fingerprint localization method to derive the initial positioning results in terms of each geo business over here. And then step 2, we make an enhancement over here. We employ the STMM, that is called shortened path and vehicle trajectory aided map matching methodology to fit the user path. At the end of the day, we derive the optimum positioning result for each sample point. And then let's look at the validation results. Still, number 1 is the accuracy of the positioning. Deviation less than 50 meters has been higher than 75.6%. And then another KPI, the average positioning deviation is less than 45 meters over here. That means what? That means more than 90% of the geo bins have been reliable that can be used for our daily optimization for every network optimization engineer in their daily work. And at last is the last key tech, we call it network digital twin, otherwise digital twin networks. We basically have developed a wireless network digital twin platform which enable us to construct the twins of each network element, definitely including the base stations, very fast in a very fast way. And then we can create the wireless network digital twin scenario to simulate the optimal network config parameters portfolio for each network optimization task over here. Basically, network digital twins is a brand new concept, basically initialized by China Mobile and China Mobile Research Institute. But in detail, if we dive into the low levels to study it, we need to productize it and we need to evolve the traditional, otherwise the legacy digital and legacy simulation results to the new generation of the method, which is called digital twin networks over here. That is the main target that we could work with China Mobile towards the future. And then let's look at some of the key effects by the initial, I would say, pilot studies of our network digital twins to work with China Mobile. Look at this KPI. First, obviously, there have been more than 10,000 digital twin instances, different network element bodies that we have created in our network digital twin library. Number 2, let's see, the average length for us, the average time for us to create a wireless network scenario has been less than 4 hours. Number 3, the 3 key simulators in this tool, coverage simulator, performance simulator, and functional, obviously signaling simulator are the 3 key simulators that we want to employ under the umbrella of the network digital twins. Performance-wise of the tool, the latency to implement any work, any command has been less than 5 seconds. So this solution has been widely applied by in China Mobile Tianjin office. Tianjin is one of the largest cities in China. The key benefits are very significant. I don't want to repeat this number again. But basically, our total solution also that we co-work with China Mobile have won some industrial awards and made some academic achievements. Definitely, we have won the 2 TM Forum awards, and the total solution have been listed by the pilot use cases of autonomous networks by TM Forum, and also the 2 total solutions. One of each is the wireless energy saving solution have won the sustainability award by Layer 123 2 years ago. And also another solution that we could work with China Mobile, the user experience optimization solution won the most innovative AI award by FutureNet last year. And also our iconic paper have been published in ITU's flagship journal 2 years ago. And also finally, our total solution have been referred by a lot of the industry groups. And at last, productization-wise, we call it Retina. So all such total solutions have been productized in this product named Retina. You know, the retina is like the membrane of your eye. We hope this tool is also the membrane of your eye to gain more insights for your network. Thank you so much, and I'd like to take this opportunity to thank GTI and Ms. Huang again, and we also hope to utilize and leverage this pilot studies and such a total solution in the space of the wireless network optimization to co-work with more vendors and telcos in GTI. Thank you so much.
Thank you, Mr. Ouyang. Very professional sharing. Any question?